Okay. Where did we end up last time? So we did that. We did that. We did midpoint, parallel and perpendicular, angle addition. Okay, I think we're right here. Nope, we did this one, right? So, well, I can review it, no problem. So if we have angle 2 is 99, then angle 4 is also 99, and then those make a straight line. So these two add to 180. 180 minus 99 is 81, and then those are vertical, so it's also 81. Yeah. That's what I'm here for. That's why they pay me $500,000 a year. No. I get paid at least $1. um we did this one, right? So if all the angles are less than 90, it's acute. If it has one right angle, it's right. If it has one obtuse angle, it's obtuse. Okay. We did square roots. Maybe this is where we are. Okay. So in the figure below, G is between E and H, and F is the midpoint of EG. So we know that F is halfway between EG. So this segment and this segment are the same length. And FG is 3, and GH, or no, EH, so this distance here is 8. So using the midpoint rule, I know that this segment is the same length as this segment. So I can put a 3 there. And now the whole length is 8, and this much is 6. So that would be a 2. Do you want to see another one of those? So they told me that this one was a 3. They also told me that this one and this one are the same length. So if that's a 3, right here, F is the midpoint of EG. So being the midpoint means that the right and left sides of that are the same length. So this would be a 3, and then we add those together to get the 6, and the full length is an 8, and that's where the 2 comes from. Okay, let's do another one. All right. EH is 11, so this is 11. EG is 9, so that is 9. And F is between E and G is between F and H. How big is FG? F is between E and G. Oh, I'm missing one. FH, so this length here is 7. So which one can I figure out from that information? So the final answer needs to be this. So I know that this one is 9, and this one is 11, and this one is 7. Well, how big is this? It's got to be a 2. Okay. How big is this? Not 2. So it's a 4. 11 minus 7. Mm-hmm. No, that's where the 4 comes from. Okay. So how are we going to calculate this length here? Good. So the full distance is 11. The left side is a 4, and the right side is a 2. So 4 plus 2 is 6. 11 minus 6 is going to be 5. You could have done that, yeah. Or we could have just, oh, you know what? We didn't even need that. If this is 2 and this is 7, then that's 5. So they actually gave us way more information than we needed in that case. Okay, we good there? Do you want to see another one? I am. I have some videos. I can show you some videos. So, graph the line. Y equals 2x, or sorry, y plus 2x equals 8. In order to graph this, we have to adapt it and make sure it's in a certain form. Right, we need it to say y equals, right? So I need to move the 2x over, and I get y equals negative 2x plus 8. So we put 8 on the y-axis, and then the slope is down 2 over 1, and there's the line. Okay. Another way to graph it is to do what we call intercept graphing. So what is the value of y on the x-axis? 0. What is the value of x on the y-axis? 0. So we can just, without adapting the equation, we can just graph this. So we want to know, where does the graph cross the x-axis? Well, we just plug in 0 for y. So if I want to find this, then I plug 0 in for y, which kills it. And then I solve for x. Yes. Yes. Okay, yeah, there's one kid. And I got a whole bunch of emails about it yesterday, but I didn't read them yet. So. Okay. Yep. So if we have 2x equals 8, what does x equal? Well, what's holding the 2 and the x together? Which operation? Multiplication. So we divide, right? And we get 8 divided by 2, which is 4. So apparently, this graph crosses the x-axis at 4, 0. Right there. If I want to find out where it crosses the y-axis, I just plug 0 in for x. So I plug 0 in here, and it destroys that. And I get y equals 8. So that's another way to graph if you want. You just plug 0 in for x, solve for y, plug 0 in for y, solve for x, and then graph the two intercepts. Now that's not going to work if the graph is vertical or horizontal. So this only works if the graph has some sort of slope to it. So it hits both axes. All right, square root 128. We factor 2 and 64, 8 and 8, 2, 2 and 2, 2, 2 and 2. And then I scratch off everything that factored. And what am I looking for? Pairs. I need a pair of numbers. So here's a pair, here's a pair, here's a pair. What do I do with every pair? Bring one out for each pair and then multiply them together. So outside, I have 2 times 2 times 2, which is 8. And then I find everything that got left behind, and it just goes on the inside. What if we have two numbers left behind? You multiply them together and then stick them inside. Yep. Okay. So two parallel lines are cut by a transversal. So that means that this line and this line are parallel. Because of that, when we slice it with another line, we only create two sizes of angles. So 2 and 4 are equal because they're vertical. But 6 and 8 are also equal to 2 and 4. And then likewise, 1 and 3 are equal, and they are equal to 5 and 7. What guarantees that that's true? The fact that the lines are parallel. So if the lines are parallel, then the left side angles and the right side angles that match up are the same size. What if the lines are not parallel? Then the angles aren't going to match. Okay? So this all depends on angles being parallel. So if 1 is 124, how big is angle 6? Well, angle 6 is equal to angle 2. Oh, 1. Sorry. So 7 would be 124. Right, 180 minus 124 is going to be 56. So 2 is 56, which means that 6 is 56. Or if you wanted, you could say 7 is 124, and then you could subtract to get that one. Okay? All right. If we have a triangle and we have 3 sides, one of the side lengths is a 2, and one is a 4, and one is a 7. Can we build a triangle with those sides? 2, 4, and 7. Why not, Isabel? Well, let's try to build this. There's my 2, and there's my 4. They've got the problem that everybody in my family has. They're just too short. 5'7". Yes. It's not much of an honor. So, how long do the sides have to be in order to make a triangle? What if they were the same? So, what if I had 2, 5, and 7? Would that make a triangle? So, if I take the 2 and I swing it over, right? And I take the 5 and I swing it over, is that going to make a triangle? It's going to make a straight line, right? Because as that 2 and that 5 come together, how far down do I have to go before they touch? Yeah. So there is a rule called the triangle inequality. And the simplified version of it basically says, in order to build a triangle, the two short sides added together have to be longer than the longest side. So 4 and 2 are too small because they're not bigger than 7. Right. Will 2, 5, and 7 make one? No, because 2 plus 5 is equal to 7. So what if I did 2.00000001, 5? Would that make a triangle? Yeah. What would it look like? Very, very skinny, right? It would almost look like a line. So you'd have your 7 here, and then you'd have your 2 and 2.000001 and your 5. So the rule for triangles is that 2 short sides have to be longer when added together than the long side. Then it's guaranteed to be a triangle. Okay? So the next question asks, will 5, 7, 8 build a triangle? Yes, because 5 plus 7 is 12, and that's bigger than 8. All right, so here we have a bunch of side lengths. Yes, it can be a triangle. No, it can't be a triangle. So the first one, 9.5 plus 3.2, that would be 12.7. Yes. The next one, 11, 5, and 3. No. 5 plus 3 is only 8. It needs to be bigger than 11. All right. So the side lengths of a triangle are sort of linked to the angles of a triangle. So the longest side, this triangle isn't drawn very well. So let me redraw it. There's my 10. There's my 8. Let's exaggerate it a little bit more. Okay. So here's my 10, here's my 8, and here's my 6. And let's call this E, F, and G. Which angle is the largest? F. Why is angle F the largest? It may or may not be obtuse. I kind of drew it slanted. So why is... So it has to do with how big the side is. What makes an angle of a triangle really large? It opens toward the largest side, right? So this angle is the biggest because this side is the biggest, right? The wider the side, the bigger an angle it takes to grab it. So which angle is going to be the largest or is the smallest? E. How come? 6 is the smallest side. So EG is bigger than EF, which is bigger than FG. Likewise, angle F is larger than angle G, which is larger than angle E. Does that make sense? So the relationship between these angles is called opposite. The angle opposite the largest side is the largest angle. Likewise, the smallest angle is opposite the smallest side. And one thing that's kind of cool here is this has no F, and the angle it creates is F. This has no G, and the angle it creates is G. So that kind of helps as you're working through these problems. Okay. I have a triangle. One side length is 8 and the other is 15. How big could X be? What's the smallest it could possibly be? No. It can be smaller than 8. You're really close though. 7. Why 7? So we know x plus 8 has to be smaller than 15, right? Whatever the angle is, plus 8, oh, it has to be bigger. Sorry, I don't know what I was thinking. Does everybody understand that? Whatever x is, when you add it to 7, it has to be bigger than 15. So let's solve this. Move the 8 to the other side. X is greater than 7. How big could it be? It could be bigger than 15. What would we have to check? This is kind of a hard one. Would 15 work? So if I had 8, 15, and 15, would that work? It would make an isosceles triangle. It's not going to be a right triangle. Oh, you're so close. How are you figuring this out? So this is assuming that that is the small side, right? So if x is the small side, then this side plus this side has to equal that side. Well, what else could x be? What if it's the big side? So if this is the big side, what would the formula be to check to see if it's a triangle? It would be 8 plus, not 7, that's when it was the small side. 8 plus 15 is greater than x, right? So if x is the smallest side, then x plus 7 have to be bigger than 15. But what if x is the longest side? Then 8 plus 15 have to be bigger than x. So we solve this. Oh, no, we don't even need to solve it. 23 is greater than x. So we just found out that 7 has to be smaller than x, which has to be smaller than 15. If x is 7 or smaller, then that x side is too short to create a triangle. But if x is smaller than 15, or not 15, holy cow, 23. If x is 23, then the 8 and the 15 are too small to create a triangle. Does that make sense? So we have to treat x as though it's the smallest side and the largest side, and then figure out what the side lengths would be. Jesse, you want to turn on that air? We're going to skip this one. Well, no, we're not. No, we're not. We might stop there. We'll do this one tomorrow. So, get your Chromebooks and get this far.